Hey Calculus, welcome to our first video lecture of many for the semester. This is what they're going to look like. It's me, a wall map, and usually Pikachu looking over my shoulder. In these videos, I want to encourage you to go against your instinct to just sort of watch and let the math happen in front of you. It's scientifically proven that what your hand writes, your brain has an easier time remembering. So in a way, you're kind of studying as you go along when you watch the videos if you're taking good notes. All right, so this video is on graphing piecewise functions. These are functions that you should have learned about in your pre-calculus class. These are functions that have two different rules depending upon which value of x you're plugging in. So just kind of a way of review. This function here says that its formula is x squared, but only if you're plugging in numbers that are less than 1. And the function is 3x minus 1 if you're plugging in numbers that are bigger than or equal to 1. Okay, so if I decided I wanted to find, say, f of 5 for this function, I would have to look at the rule and say, well, 5 is bigger than 1, bigger than or equal to 1. So we would have to use the formula 3x minus 1. So f of 5 is 3 times 5 minus 1, which is 14. So we would never plug the number 5 into the x squared formula. If we wanted to use the x squared formula, we'd have to pick a number that would be less than 1. So we could plug in like -1, f of -1. That we would plug in to x squared, and we would get +1. So these functions sometimes I refer to as Frankenstein functions because we're going to chop up a bit of this function and a bit of that function and sort of stitch them together to make a piece together function, a piecewise function. So now we want to graph this function. So to do this, we're going to pretend like we don't know we're in the middle of a piecewise function, and we're going to graph these two formulas as if they're two separate problems. So I'm going to graph y equals x squared. I've already plotted a point for y equals x squared. I found -1 squared was 1. So I'm going to plot the point -1, 1. And then we'll just plot a few more points. So if I plugged in -2, so -2 squared would be equal to a +4. So -2 squared is 4. 0 squared would give me 0. 1 squared would give me 1, and 2 squared would give me 4. And we see that familiar parabola shape showing up, so I'm going to go ahead and draw that in. All right, now we're going to graph the second equation, 3x minus 1. I'm going to do that in a pink pen. Hopefully we recognize that is the equation of a line. Y equals 3x minus 1 is a line with a y-intercept at -1 and a slope of 3. So I'm going to mark my y-intercept at -1. And I'm going to do my slope of 3. Again, we think of 3 as being 3 over 1, rise over run. So we're going to go up 3 and to the right 1. So I'm going to go up 3, 1, 2, 3, and to the right 1. That lands me at 1, 2, up 3 and to the right 1, up 3 into the right 1. You only need 2 points to graph a line, but you can graph as many as you want. Instead of going up and to the right, you can also go down and to the left. So I could, from that -1, go down 3 into the left 1, down 3 into the left 1, as many points as you wanted to draw. And we're going to connect that with a straight line. All right, so now we're going to do the Frankenstein bit where we chop up a bit of the blue graph and a bit of the pink graph and put them together in our graph of f of x. So let's pay attention to those interval parts of the function. So f of x says, I love the graph of x squared that you drew for me, but I only want it if x is less than 1. So let's think about x less than 1 in terms of a number line on the x-axis. So x less than 1 means that we want everything to the left of 1, but not including 1. All right, so I'm going to shade to the left of 1 all the way up until I get to 1. And then I'm going to draw an open circle at 1 because I don't want to include 1. All right. I'm going to do the same thing for the pink interval. I'm going to slide this blue one down because we're getting a little crowded. So let's put this down at the bottom of the graph. We'll just kind of keep that as a reference there. All right, so the pink graph says, I want that graph of 3x minus 1, but only if x is bigger than or equal to 1. This is where we draw that filled in circle at 1, and bigger than or equal to means to the right. So I'm going to fill in at x equals 1 and shade to the right. All right, so that's the only part of the pink graph that this function wants. And again, I'm going to slide that down so it gets out of my way. All right, so we're only going to keep the blue graph on the blue half of the paper, and we're only going to keep the pink graph on the pink half of the paper. So I'm going to do this in my final answer pen, which for me is a white pen. All right, so I'm going to trace over the graph of x squared, my blue graph, but only at x equals 1 and to the left. All right, so I'm going to trace over the left half of my x squared graph. And when I get to x equals 1, I'm going to draw that open circle that says I don't want that point. And then I want to get rid of the rest of that blue graph that I drew. So this is a little bit easier for me on a computer. I can just kind of circle it and say, go away. And I just want to keep that white graph. And then I want to do the same for the pink graph. I only want to keep the pink line on the pink half of the paper. So I'm going to go at x equals 1. That's the point 1 comma 2. I'm going to draw that filled in dot, and then I'm going to go to the right. And then I'm going to get rid of my scratch work, which was my pink pen. All right, and there, that white graph is my final answer. This is the graph, those two pieces taken together is the graph of f of x. And a quick check with the vertical line test shows that this actually is the graph of a function. Frequently when students make a mistake graphing a piecewise function, it leaves them with something that doesn't pass the vertical line test. So anytime you're graphing a piecewise function, always double check to make sure that it passes the vertical line test. We'll do one more graph in the next video.